So, as I was saying in the last video, we have a similar and analogous system for cosecant, cotangent. There was accidentally a typo in here. It should be cotangent of x and cosecant of x instead of tangent and secant, of course. That was a little copy-paste error that I will fix for future semesters. So if you're watching this in later semester, you won't have that typo. All right, so we're going to evaluate this integral, and this is a little tricky one, so I enjoy putting this one in here. Now, it doesn't strictly fit into any one of these categories. It sort of fits into the second one, because m, which is the power of cotangent, is odd. However, if you look at what it says to do, it says to split off a cosecant cotangent. Well, I don't have any cosecants, so there's nothing to split off, at least right now. All right, so let's rewrite this, because I know about the Pythagorean identity. And the Pythagorean identity says that cotangent squared is cosecant squared minus 1 of theta minus 1. And that's the Pythagorean identity. So actually, let me even do it this way here real quick. Let me rewrite it this way. Cotangent squared of x of theta times cotangent of theta. Okay? D theta. But then by the Pythagorean identity, this one right here is cosecant squared of theta minus 1 times cotangent of theta, d theta, which would be equal to the integral of pi over 6 to pi over 3 of cosecant squared theta cotangent theta, that's interesting, minus cotangent theta, d theta. Now, why do I say that's interesting? Because this one will fit into our format. Cotangent is raised to the 1 power. So if you look at this step right here, m is 1, which is odd. N, which is the power of cosecant, is even, right, which is 2, which is even. And so yet again, we can choose to use either method 1 or method 2. It's entirely our choice. So we can split off a cosecant squared, right, this cosecant squared right here, and then make u equal to cotangent. Or we can split off a cosecant cotangent and make u equal to cosecant. Either way you like. All right, now that's that one. This one, cotangent of theta, well, that's an integral we sort of know, but we could also rewrite it. That's not going to work off of the same methodology as up here. So we're going to do two things. We're going to split this into two integrals. So I'm going to say d theta right here, and then I'm going to have another integral from pi over 6 to pi over 3 of cotangent of theta. And I'm going to do two different things with them. All right, so the one on the left, I'm going to use technique number 2 because I already showed technique number 1 for the last problem. So let's use number 2. Why not? So this will be the integral pi over 6 to pi over 3. And then I'm going to let you, I'm going to split it off and make it a cosecant theta, cotangent theta. And then I have another cosecant theta, d theta. So cosecant, cosecant, cotangent. I'm going to let u be equal to the cosecant of theta. And then du, right, which is right here, there's cosecant of theta. And then du would be equal to the cosecant of theta, the cotangent of theta, d theta. Because the derivative of cosecant is, it's negative, actually. So then I want negative du, which is cosecant theta, cotangent theta, d theta. All right. So then this would change. So this will become an integral of u du, because this and this make du, but they make negative du. So it'll be negative du. Now my limits of integration have to change, right? Because they're no good to me as they are. So I would want to change the numbers into something else. So if theta is equal to pi over 6, then cosecant of theta, which is u, is the cosecant of pi over 6, which if you remember is 1 divided by the sine of pi over 6. And the sine of pi over 6 is a half, so this would be 2, right there. All right, then if theta is equal to pi over 3, then u is the cosecant of pi over 3, which is 1 divided by the sine of pi over 3, which would be 1 over the square root of 3 over 2, which is 2 over the square root of 3. So that would be my next number up here. And just to double check my work here, let me make a little unit circle very quickly and remind you that pi over 6 is over here. So it's square root of 3 over 2, a half. The sine value is a half. Pi over 3 is up here, and that's a half, and then the square root of 3 over 2. So my sine values are correct. This is right. Okay, so that's that piece. I haven't finished the integration, but that's where we're at with that. So, and then meanwhile, the other side, which I've delayed dealing with, the cotangent is the integral of cosine of theta over sine of theta, d theta. And I'm taking that from pi over 6 to pi over 3. Well, that's going to be a different u sub. We've actually already done this u sub. This is u equals the sine of theta. So du is, oh, I'm going to have to kind of squeeze this over here to the right. Let me do that over here. So du is, derivative of sine is cosine. And then for my limits of integration, again, when theta is pi over 6, right, u is the sine of pi over 6. The sine of pi over 6 is a half. And when theta is pi over 3, u is the square root of 3 over 2. Okay, so putting this all together, here's one u sub over here and another u sub over here, right over here. So this is u sub number 1 over here on the left, and this is u sub number 2. And we're doing 2 of them simultaneously in the same problem. Okay, so here's u sub number 1 right here, right? So we change those limits of integration, minus, and then now I need u sub number 2. So I'm going to go from a half to the square root of 3 over 2, and then it's 1 over u du. Right, because cosine and d theta together make your du. Okay, so now I just need to integrate and I'm done. So the integral of negative u would be negative 1/2 u squared. So I'm going to take that from 2 to 2 divided by the square root of 3. And then minus, and then this will be the natural log of the absolute value of u. I'm going to take that from 1/2 to the square root of 3 over 2. And at this point, it's just substituting very carefully. So I have negative 1/2 times 2 over the square root of 3 squared minus a negative 1/2, so that's plus 1/2, 2 squared. I'm actually going to change that because that just makes common sense. Minus a minus is plus. So negative 1/2 2 square root of 3 squared minus a negative 1/2, so plus 1/2, 2 squared, minus, and now the natural log of the square root of 3 over 2. I don't need to worry about the absolute value because the square root of 3 over 2 is positive. And then minus, because this whole thing is the first term, and then minus, and then this whole thing will be the back term, the natural log of 1/2. All right, so here, this is 4 divided by 3, and then divided by 2, right? So it's 4 over 2 times 3, because when you take the square root of 3 and you square it, it becomes positive. So that would be negative 2 over 3 plus, again, 4 divided by 2 is 2, minus, and then this will be, if you think about your rules of logarithms, there's a rule for this one. It's a quotient rule of logarithms. So this is the natural log of the square root of 3 over 2 over 1/2. right? It's the subtraction turns into division with logarithms. The quotient property for logarithms right here. Right there. So that's what I just did. So why did I do that? Well, because then the 2's cancel, right? Because they're both in the denominator. So you're left with 2 take away a 2/3. So that's 6/3 take away 2/3. So that's 4/3 for these two numbers right here, minus the natural log of the square root of 3. This is all well and good. Remember that 3 is really, square root of 3 is really 3 to the 1/2 power. So you could also write this as 4/3 minus a half times the natural log of 3. Right? Because you bring the power down in front with a logarithm. So if it's the natural log of 3 to the 1/2, you can bring the power down. Sorry, my natural log got weird there. There you go. Tricky, very tricky. All right, so let's back up. We used Pythagorean identity. Oh, I forgot to label it. So right here, that was Pythagorean identity to bring in a cosecant squared minus 1. Then we split it up into 2. The techniques on the top of the page actually applied to this one on the left, which meant we had to do this whole u substitution thing, right, which is over here. And that got us this bit on the left over here. So that's u sub number 1. And then over here on the right, cosine over sine, right, which is what cotangent is. And then we did a little u sub over there, and that gave us this one. And then together, putting them together, we have the one over here on the left minus the one over here on the right. And then algebra took over, right? And we used our logarithm properties.